Hello everyone, this is another student's quest. The students asked this question: find the equation of the line that is tangent to the curve at two distinct points. And in students' words, maybe paraphrasing, that is, though it's looking very easy, but it is difficult when we start solving it. So let's try to understand. And one thing I want to share, that this question is relevant to the current ongoing classes what I'm taking offline, and in actually the tangent and normal chapter. So I gave this question to my students, and one solution I got from the students' sides, and there is very intelligent thinking, so I will also discuss that thing. So the idea is that there is a biquadratic curve, and I have, so suppose I don't want to find any derivative, or maybe I don't want to use calculus. So what I can think, that since there's a biquadratic, it may look like this. Let me just remove the y-axis because I don't want to. Okay, so suppose there's a biquadratic kind of a situation. There are four roots. I have 1, 2, 3 and 4, and perhaps the curve is touched by the tangent somewhere here, like that, at 2 points. I mean, the tangent is there at 2 points. So this is the same tangent at two distinct points of the same curve. So I have to identify what this tangent equation. Suppose I draw the tangent over here. I have to determine what is the equation of that tangent. So to do this in a non-calculus way, what we can think, that suppose I have an equation y is equal to mx plus c, which represents a straight line, and that's one that actually this line wants to be tangent of this curve. And we can think that since this line is touched by this curve at two distinct points, but there is no such four solutions are happening. Otherwise, what would happen? It will intersect at 4 points. And so we think that this line is touched at these 2 points. So maybe what is happening, that the fx minus mx plus c, that solution, whatever you get, that solution must be equal to one such kind of a quadratic, rather two quadratic, which has, both have equal roots. Then only it is possible. So from there, what we can do, that function I can write also fx is equal to x minus alpha square, x minus beta squared, and plus mx plus c. Now all that what I have to do is to equate this fx, what is given, and on the right hand side I have also a biquadratic. So I have this biquadratic, I can write as x squared minus alpha plus beta, x plus alpha beta, and then mx plus c. Our aim is to identify the m and c so that I can write the line. So let's assume this alpha plus beta as some constant. So alpha plus beta I am assuming as s, and alpha beta I am assuming as the product p. So I can write this as x square minus sx plus product p, and then plus mx plus c. Now what I have to do is, I have to write this function again, left hand side. Let me write it. So that is going to be x cubed minus, let me just copy this thing there. So this is the left hand side I have, and from there I want to compare the coefficients of, this is square by the way, I want to compare the coefficients of the each term. So what I do, I will expand this thing, and I will get x to the power 4, and minus, or rather s square x square plus p square minus 2s x cubed minus 2s px plus 2px squared, and this is mx plus c. Now we compare the coefficients, and the coefficients of let's say compare this thing. So first x square I'm getting these two places, so let me mark it, this one and this one, and on the left hand side I have the x square, that is a minus 2, so I can write s square plus 2p is equal to negative 2. Similarly, I will compare the minus 4 with the coefficient of x cubed. So this is going to be x cubed here, and that is x cubed there. So I'm going to get is minus 2s is equal to minus 4. Therefore, s is equal to 2. I got. Remember, I have to find out the m and the c. So let's substitute this s there. So I'll give you 4 plus 2p is equal to minus 2. So p will be minus 3. So the product is minus 3. If you want to find the points, you can also find it, because I need their product of alpha and beta, and I assume that the points coordinate, the x coordinates are alpha and beta. So we are looking for the two distinct x coordinates whose sum is minus 3 and the product, the sum is 2 and the product is minus 3. So we can also find like that, but we can find the m and c. And now we compare the coefficient term. So the x term first. So x term is only there, then those two m, x, and this thing. So let me write m minus 2sp is equal to the 5, and so we have s and p both, so let's substitute it. So m minus 2 and s was 2 and the p was minus 3. So from there the slope I'm getting is what is that? 5 minus 12. 5 minus 12 is negative 7. So m I got as minus 7. Once I get m, I have to find out the c only, and that will be the line equation we get. So now let's see that there's a c is here and constant, and this is p squared. So I can write, compare with the coefficient. So c plus p squared is equal to 2, and p is already, we have got 9. So c is going to be 2 minus 9, that is negative 7. And so we have the value of c and everything. And so the line is, I got the tangent, what I'm looking for is y is equal to minus 7x minus c, and that's the answer. So this is one way to do it, and that's a very like a what we call mechanical way, because perhaps we are not getting the feeling of correct understanding of the picture. So let me go through the tangent and normal topic way, and we will see how we can do it in that way. So that is going to be here. Let me again copy this. Okay. Now, this is actually a little bit rigorous way, but it's also smarter. Let's try. So the idea is that I have this. Let's first try to understand the graph of it. So for that, I try to draw the graph just by no calculus, just by guessing. You know that there is the fx, and the fx is a biquadratic. So the biquadratic means at minus infinity, it should have a value from here. I don't know, it is coming from down, from the top, very high, and at 0 the value is 2. So at 0 the value is 2. We will see it. So maybe it will go like this, or maybe it will go like this, who knows. And then we'll take the 4 roots, because at minus infinity also it's going from the coming from the infinity, and at plus infinity also it goes to the infinity. So for that, I just stop it, the idea that to draw the graph, and then first we analyze some other things, and then we come to the graph. So that thing we must know that is coming from there, that thing we know that, and at 0 it is 2, so it will hit it, but I don't know whether it's hitting like this, because maybe all the roots are positive here. Okay, who knows. There are some other rules to find out all the roots are positive or not, but that I'm not going to it. So let's be a little bit simple. So what what we get the derivative here, f dash x, that is 4x cubed minus 12x squared minus 4x plus 5. Now what the students suggested, that is very interesting. What they said, in fact 2 students worked on it separately and then they got the same idea. So what is that one is f dash x here, and these two I can take common. What these two I can take common? 4x cube minus 4x means I can just make it 4x cube minus 4x here, and then I can write minus of 12x square minus 5. So let me do it in a different way, what I thought and what I was thinking students to do, but the students are smarter than me sometimes, not always. So but let's see what they think later. So what we can do, that we are looking for the values, two values of x such that the f dash a must be equal to f dash b. Means I am looking for two such values of x at which the slope are positive. Slope is positive means slope are equal actually. Why I am looking for it? Because at those points the same tangent you are drawing. But there is one loophole here, that you are comparing the slope. It can be also possible that the slopes are getting equal due to the fact that the two lines are parallel. So we'll just manage that thing, but let's assume that the f dash a and f dash b are getting the slope of a same line at the two different points. So let's say a and b are that points. So let's substitute it there. So what we get here, fa cube minus 4a is equal to, minus minus 12a squared minus 5. And the right hand side, what we get it here, 4b cubed minus 4b minus 12b squared minus 5. Now you notice that this 5 and 5 will get cancelled. I want to take all these things together in such a way that it will be manageable. So what I'm going to do is that there's a 4 times I'm writing a cube minus b cube. Then again minus 4 times a minus b. You notice what I'm doing. This term and this term I'm combining. Minus 4a minus 4b I'm combining, and 5 and 5 got cancelled. And also on the right hand side I'm sending this thing. So this will give you 12 times a square minus b square. I hope you understood. Now I can take this a minus b as a factor common, and this 4 and 4 will also get cancelled by 12. Means like this. A minus b is out as a factor on this side, and here I get a squared plus b square and plus ab, and here I get minus 1. Yes, because 4 I have taken, and here I get 3 times a plus b, a minus b. You notice that a and b are distinct numbers because of course we are comparing the slope of that tangent at two distinct points, so a and b are not equal. So since a and b are not equal, I can just remove this a minus b factor out. Once I get that, I am in the situation to find out this thing, a squared plus b squared plus ab minus 1 is equal to price of a plus b. Now can we guess, and can our guess will work in nice manner so that I will get the two values to hold this equation? If guess works, then I got the 2 points actually, means a and b, the x coordinate at least. So let's try. So the usual guess what we do is like suppose I want to make both sides 0. So we'll try to actually put such values so that both sides, so this I can assume that let's say a is equal to 1 and b is equal to minus 1. And in such kind of question they have there's a like a huge opportunity, or maybe the huge possibility to get this kind of guess. So suppose I put a is equal to 1 and b is equal to minus 1, what we get that side is 0 actually. and a is equal to minus b, a is equal to 1, b is equal to minus 1, that will give you 1 plus 1, and there is a minus 1 and minus 1. So you notice that this is also minus 2 and plus 2, so it will become 0. It doesn't matter which we take 1 and which we take minus 1, because this whole thing is symmetric, and here also symmetric. So if you take b is equal to 1 and a is equal to minus 1, same story will be there. So we actually got the two x coordinates. The x1 I can take as 1 and x2 I can take minus 1. So let's assume that the 2 points I got, as the one point is 1 comma f1 and the point b is minus 1 comma f of minus 1. But the problem in this is I don't know whether this a and b are those points at where the tangent is the same line, because it can be also possible at this point you are drawing a tangent, the slope of that tangent is equal to the slope of the tangent at b. So we'll come to that, but let's see what is happening over here. If you are putting x equals to 1 or x equals to 1, because you know the point, so what is the slope we got? So the slope at 1 and slope at minus 1 is same. So let's say slope at a and b, actually whatever it is, the f dash minus 1 or f dash 1 should give you the slope. So what is f dash 1 we get? Let's see, this is our expression I have, so we'll substitute that. So 4 times, and let me just take it there so that I can substitute it and you will see it better. Okay, so this is our f dash x, so let's substitute it. So we get it here 4 times, why I'm writing like this, 4 times 1, so that is 1 I have to substitute. So we get 4 minus 4, and this is minus 12 minus 5, so we get the slope is negative 7. And at minus 1 also this will become 0, you see. So that is also minus 4 and plus 4, and here we get again 12 minus 5, and that is going to be negative 7. So at both points we are getting the slope negative 7. So what will happen? Are we getting the same line? So we'll see it. So we got the slope at 1 and minus 1, both is negative 7. So can we have other point also where this slope is the same? So we are looking, because the cubic equation you can notice there. So this cubic equation must have 3 roots if you are equating with 0. But is it also possible to get the same value at 3 distinct points? Let's see. So suppose I substitute there this 4x cubed minus 4x minus 12x squared minus 5 is equal to minus 7, means I am hoping that this again I will get some other values of x at which this slope will give you the value minus 7. So we can do this easy calculation like this, 4x cubed minus 4x, and I will send this thing this side, so we'll get it 12x squared and plus 5 and minus 7, so it will become minus 12. So from there I'm getting is 4x common again, so we get x squared minus 1, and here also 12x squared minus 1. Notice that we have already cancelled those x's. X squared means we can cancel those x's, x squared minus 1 and x squared minus 1, which were giving the previous two values we got here, 1 and minus 1, because this equation will satisfied by is satisfied by minus 1 1 and also 3. You can notice that if I just equate this thing, means cancel this thing, I get x equals to 3. It means now we have 3 values, all the full 3 values at which the slope is going to be negative 7. So at 3 also we have to find out what point I am getting, means what coordinate I am getting fully. So let's just find the coordinates. So I have 3 points basically. The first point is a 1 comma f1. The second point is b, that is a 1 minus 1 comma f of minus 1, and the third point C is going to be 3 comma f of 3. Now the thing is, suppose I take the point A and B. Now let's try to understand the graph. So what is the value of f1? Let me take the function fx again, and okay, and I will substitute in that. So just keep patience. So this is a function I have, and let's substitute these values there. So at 1, what I'm getting there, f1 is going to be 1 here, and 1 minus 4, and we calculate it. I think f1 will be 2. What is f minus 1? F minus 1 will be 0, and f3, if you calculate, you will get minus 28. Now these are the values. So now let's try to draw this graph and analyze which actual tangent we are looking for. So the idea is that here, actually I plotted there the axis, but I didn't draw the graph there because let's see here. So we already know that there is a minus 1 comma 0 there, means at minus 1 the graph should hit the x-axis. So let's say this is minus 1, and it is coming down from here somewhere, and at 2 actually it has to be 0, the value means at 0 it should be the value 2. So this is 0 comma 2, so it will again go up there to hit that 2, but notice at 1 again the value is 2. So suppose I have this value 1, so it will come down after some moment in the same height at 2. So this is 1 comma 2 by the way, and again it should come down, and at 3 it is going to be minus 28. So at 3 that value is minus 28. So let's say this value is 3, and it's going very down to hit minus 28. Let's say this value is 3, I don't know where, this is minus 28, let's say, and again it will go up and it will reach to infinity. So this kind of graph, this is a straight line, but you understand this is the curve actually. Now what is happening, you notice that at negative 1 the slope is going to be minus 7, because we have already found that there's one point at minus 1, second point at 1, and the third point is at 3. So the slope at minus 1 is going to be negative 7. So this is the point minus 1 there, and I have this line minus 7. The same line with the slope minus 7. So same line is going again, or perhaps my graph is bad, but it is actually like this and is again hitting this point. So let me try to convince you by taking a little bit longer graph here down. So this is minus 3 here, and you are drawing this tangent, and this is the point here, you are getting the same tangent back, means at this point minus 1 comma 0 and at 3 comma minus 28 is the same, because if you take the point 1 comma 2, at 1 comma 2 there is no chance that we'll take another tangent again, means the tangent you draw at 1 comma 2 again cannot be the tangent at other point. So this is this point y came algebraically because this has the same slope at 1 comma 2, because their two lines are parallel, and that is why the 2 points we got 1 comma minus 1, sorry 1 comma f1 minus 1 comma means 1 comma 2 minus 1 comma 0 in the first case, because they are symmetrical in this region, and in this symmetry we can think that this slope here and the slope here are same. But when you go ahead at 3 it is getting down very deeper, and at that point also the same line is coming and getting the tangent to it. So this is the whole scenario we have. Now what students thought in a very short quick way, I was about to teach them this method, but they were very smart, I mean they are actually. So what they thought that here, let's see, they think that after grouping this thing, what we can assume that because I need 2 points that with the same slope should be there. So what they thought that this is already an even number, like even function, means there's a power is 2. So if I kill by any chance at the x, by any chance at two distinct x I can kill it, at the same two distinct x it can give you the same value, means the one plus and one minus, because it's an even number. So at, let's say at minus a, and or let's say minus b and it's plus b, or minus x or plus x, this will give the same value. It means the same minus x and plus x, that should be 0. And after complete simple guess, we can think that this can be 0 when x equals to minus 1 and plus 1. Therefore, directly we could find that at minus 1 and plus 1, this is 0 and this is giving the same value, so the same slope as minus 7. And we get this minus 7, the third point we can find by equating this as minus 7, that what I did in the in this method. So in this way we can solve this question. If you find any other way, then please share with me. I will be happy to accept and learn from you. So see you in the next video with some other interesting question sent by a student. Till then, stay math active.